Hello and welcome to today's webinar, Actuator Replacements for Fire and Smoke Damper Applications, presented today by Larry Felker. Thanks for joining us. My name is Ron Pilkowitz and I will be your moderator today. Because you may want to watch this webinar again, it will be recorded and available on Belimo's YouTube site. We will have a question and answer session at the end of this presentation, so please at any time, type your questions into the question box and I will read them aloud during the question and answer session. Larry will answer as many questions as we have time for, otherwise you will receive an answer via email. I would now like to turn the presentation right over to Larry.
Hello. This is replacement actuators, but we are going to be wanting to start with the damper. And I'll rub in why we're going to do that shortly. So here's the agenda, and it's primarily the replacement nuts and bolts. Code required testing. The International Fire Code refers to NFPA 80 and NFPA 105 for the primary testing rules. Building owners are responsible. They are supposed to be testing most of their dampers every 4 years, except houses every 6 years. And that's the rule for containment dampers, which are about 85% of the market. Those are the ones that are defined by Chapter 7 of the Building Code, the IBC. And NFPA does add some of the requirements for the smoke control system dampers, which are the requirements are defined in Chapter 9 of the International Building Code. So any Chapter 9 damper that's dedicated, that it's only for smoke control purposes, they're supposed to be tested twice a year. And any that are non-dedicated, which tends to be the HVAC system, those are supposed to be tested annually. So there's a lot of testing requirements, and they are not obeyed well, and they're not enforced well by the fire marshals or the building officials. But it is the building owner's responsibility. The codes and standards, we're not going to get into these in any depth here, but UL 555, the family of standards, are those which define the requirements for dampers, and they're primarily factory construction. They also refer to the damper manufacturer's instructions, which are to be followed for installations. But all of the installed dampers are regulated by the authority having jurisdiction, the AHJ. And they are involved in the new construction also for the approval, seeing that they're tested and commissioned. And it's very important, the International Fire Code, the IFC, references NFPA 80 and 105. 80 is fire dampers and fire doors. 105 is smoke protectives. And that would have the smoke dampers. So those are the two guiding standards for repair and replacement, 80 and 105. So the subject here, we got problems over there on the left side. Old motors, defective motors, and Belimo has various solutions for them. Start with a damper, not the actuator. I get pictures sent to me of an actuator. Well, I don't know how it's been applied, nor do any of our other people. We need to get a good picture of how the damper's being controlled overall. And we're going to see some examples here of various ones where they're a little bit weird. 80% of the replacements are real easy, but 20% get weird. And you need to investigate a little bit. And once you see how the mechanisms are working, no problem for replacement. But sometimes we have to disable an old spring or make a little change. to bring it up to modern standards. So you can see that one on the left there. Why I say start with the damper is, well, I need to see how to mount it. Am I going to need a linkage, or am I going to be able to direct couple? Those motors look like old Barber Coleman MA 418s, but they're not. They're a Phillips motor. They're non-spring. The spring is actually on the damper shaft, and it needs to be disabled. And of course, we see the proverbial piece of wood holding the damper open. So on the left side there, well, if somebody just sends me a picture of that motor and pulley, I don't know how it's been applied. And I need to look at it and see how it's connected. Where is the fire mechanism, the primary heat responsive device, and see how I'm going to recontrol it. And in that case, well, the way to go is with a linkage. They're on fairly small dampers, so it's no problem as far as torque goes, but space constraints exist when you're trying to put a actuator and linkage together. So here are the types of life safety dampers. Ceiling radiation on the top left. Fusible link holds that damper blades closed, and if it melts due to seeing 165 degree F or higher temperature, this link melts and the spring pulls those blades closed. Those do not need to be tested per codes, and they're never actuated. Pictures of a couple of types of fusible links are there in the middle. There are a variety of different types, different manufacturers have used over the years. Curtain dampers on the far right. Most of them, gravity pulls them closed if the fusible link at the top breaks. Many of them today are spring-loaded. There's a static versus a dynamic type, and horizontal ones have to be spring-loaded. However, they're never actuated, so there's no problem with those as far as testing and repairing the actuators. They are required to be tested per the schedule, NFPA 80, but they're never actuated. When we get to smoke dampers and fire and smoke combination dampers, the bottom left, there's where we start to see actuators all the time. We have a mechanical way of measuring heat. We're going to melt a fusible link, but we have no mechanical way of measuring smoke. So it's the smoke damper part of the assembly that requires an actuator, because we're going to electronically sense smoke and then cut power to the actuator and let it spring close. On the far right bottom, a multi-blade fire damper. There's not too many of them installed. They're certainly better quality than the curtain damper, but they're typical of a lot of the old dampers you're going to run into. We'll detail that shortly. So smoke and combination smoke dampers are the actuated ones. The blades must be in the plane of the wall unless there's a heat wrap put around them. So they're almost always jack shafted. And the knee lock is the mechanism in the center that holds those blades closed if they've slammed shut. The combination fire and smoke damper has what UL calls a primary heat responsive device. It's a bimetal Thermodisc type thing with their manual reset. So you can see the actuator springs closed if power is cut, and that manual reset must be pressed before they're going to work again. So now the core of our subject. There are times when you should replace the damper, not the actuator. So the one on the left there is a good example. You're never going to fix that damper. Replace it. It's very expensive, but it needs to be done. And of course, it's a lot less expensive to replace an actuator. The one on the right, well, they broke into the drywall to get to the damper shaft and to get it mounted. And this is just a clear code violation right from the beginning. They either need to put a modern damper in there, or possibly they could put sheet metal behind that shaft and seal up that hole. But it's pretty messy. Really, the damper should be replaced. So you don't always try to replace the actuator. Here's your multi-blade fire damper, and it's typical of the vast majority of old dampers. So all the parts are labeled there. The spring is on the shaft, and that's the important part of that. The fusible link and connection arms are over there on the right. If we see temperatures rise to 165 F or higher, then the fusible link melts, and that spring then grabs the blades and slams them shut. Now, the reason why we mention that is because the typical old fire smoke combination damper was the same as that fire damper, except that it had an extended jack shaft where they could mount an actuator. So you'd put the actuator on it, and if the fusible link is intact, that spring was no load on the damper, except for some old Prefcos. And you could easily open and close the damper with an actuator. If smoke was observed, the smoke detector would cut power to the actuator and it would spring the damper closed. If you had a high temperature, the fusible link would melt and the shaft spring would close the blades. So when we start looking at applications, 80% of them are going to be quite similar to what we just looked at. All your modern dampers, the spring is in the actuator or it's externally you can see it, and you're just going to remove the old bad motor and the old spring and direct couple an actuator on it. So this would be typical. This is the Barber Coleman or the CBMA 220. They're no longer manufactured. The motor was non-spring. The spring is that white arrow. It's underneath the little housing there. And when you go to remove it, you have to remove the old spring as well as the actuator. So you'd end up looking like this. This is the same damper. So you just drop an actuator over the shaft after removing everything. And this is going to be a constant theme here among a few pictures. Just find the damper shaft, direct couple over it, and now you've got a setup that looks like a modern damper. So here's your common Honeywell. Well, it's direct coupled right on that shaft. The spring is in the actuator, so there'll be no problem in replacing it. Now the method 2 are the old dual spring motors, which is the most common, dual spring damper. So you've probably got one spring for the fusible link and one for the actuator. So you're going to remove the old actuator and its spring, but you're not going to touch that internal spring. So on the left side, there's a shaft spring. Leave it alone. You don't have to mess with it. On the right side, well, you're not going to try to replace the motor and put a linkage on it. You're going to take off the old motor, linkage, and the bracket. You are going to leave the bearing. You don't remove any bearings. So between the fusible link arms and the external shaft, you got a bearing in there. You don't remove that. It's needed for the shaft to rotate. So here again, we don't try to replace just that old motor. We're going to get rid of that screen door spring, the old motor, We're going to take the linkage and the cable off. And now you've got the damper shaft. The orange arrow points to it. And you're just going to direct couple right on that jack shaft. So you're simplifying and bringing it up to a modern standard. So springs easily seen. So that motor and spring assembly are just like a modern Belimo. You can pull everything off and direct couple. The toughest part of it is in the anti-rotation straps so that you can connect it to back end. Another case, same thing. On the left side, you've got what looks like assembly, but you're not going to try to replace that old motor. You're simply going to go direct couple to the damper shaft. And on the right side, you can see that the old motor is there at the top. You can see it's sticking out. It made a nice space to mount the anti-rotation strap, so we didn't even remove the old motor. Then the actuator, when it's put on there, well, the damper shaft was short, so we put the clamp on the inside and mounted it there. Now the weird ones, the 20%, probably not that high a percent anymore, they used one spring for both the actuator and the fusible link. And in this case, you got to go add the manual reset primary heat responsive device. So typically the old motors were non-spring, and you had a shaft spring, and there was a fusible link. So the left arrow points to where the fusible link was located. You got to take it off to hold the mechanism together, and then you're going to unhook that spring. And then you go to the outside of the damper and you have to add a heat responsive device. So it's a bimetal manual reset. They're commonly available from any of the damper reps or the Belimo BAE could be used also. This was how Pautor did theirs, and there were a few other cases. The Negator spring dampers, there were a lot of these out there. Every month I get one of these. They were complex, and they can be recontrolled, but they take a little bit of work. I'm not going to go into the details here, but the point being, over on the right side at the bottom, there, when the motor drove open, it pulled that spring open via the blade. And at the above it, this is a fusible rod instead of a fusible link. That rod would melt, and then the blade spring would pull the blades back closed. The pneumatic ones were very easy because they had a shaft extending. The electric ones need a little bit of and it's the one wiring diagram that should be memorized. It's fairly simple there. On the left side, you've got your smoke detector. It's very often a duct smoke detector. It could be a relay from an area smoke detection system. But you've got a normally closed contact. Power comes in from the left and goes to the smoke detector, then goes to the thermal sensor that's mounted on the damper. That's closed. And then the actuator gets powered and drives open. If you see smoke, that contact opens. If high temperature exists in the damper, then the thermal sensor opens and the actuator springs closed. So it's simply two switches in series. The actuator and damper are not connected to the alarm system or the firefighter smoke control system in the Chapter 7 damper, the 85% that are for containment. The alarm system is notified by the smoke detector. Torque requirements. This is always the big question that comes up. Here are the rules of thumb, and we have a list in every one of our instructions on our website that gives you torque. So at the top left, our little FSTF, well, it'll do about 50% of the dampers that are installed. We say that it's for less than square feet, 2 square feet. It has passed UL at bigger sizes, but given corrosion, duct shifting, and so forth, you're safe with 2 square feet. At the bottom left, the FSLF, well, about 30% of the dampers are between 2 and 4 square feet. So fully 80% of the dampers out there are the small dampers. Top right, well, between 4 and 12 square feet, we would say to go to our FSNF. It's past UL as much as 16 square feet, but again, corrosion, duct shifting, dirt, it's better to have more torque than you need. And then when you get to the larger multi-section dampers, which is about 5 to 10% of the market, we would recommend our FSAF or our big modulating actuator. You're not going to remember everything we say here, and it is a little bit too much information, the instructions. The other way to look at it is just to go with a torque requirement rule of thumb. This is more an art than a science, because different manufacturers and different ages of dampers and condition really causes you to have to use a little bit of judgment. But for a parallel blade damper, which most fire smoke dampers are parallel blade, what you're going to need anywhere from 4 to 7 inch-pounds of torque per square foot. It'll be nearer 4 for the smaller dampers, nearer 7 for larger dampers. And if you do have an opposed blade, well, they require less torque. So 4 to 5 inch-pounds of torque per square foot. Those are very safe rules of thumb. There are a lot of ifs, ands, or buts. For example, FSLF actuator, which is 30 inch-pounds of torque, well, it'll pass UL 555S with a 2 foot high by 3 wide, but it won't pass a 3 high by 2 wide, because the torque load starts to become higher as you get a taller damper. So the condition of the damper does need to be considered. If your static is above 4.5 inches of water column, go with more torque. If your velocity is greater than 2,000 feet per minute, then you're going to need more torque. And if you've got linkages that you're applying, sometimes the linkages translate to torque and change the torque curve, so it doesn't, you don't get a nice 90 degree actuator to damper relationship. So you have to start to add a little bit of torque to adjust for the linkage. It's difficult to tell. And then anything over 12 square feet, you start to see more of a torque requirement than per square foot than for a smaller damper. But we do have all the rules of thumb and recommendations in our instructions. Pneumatic to electric, very common now. Top left there, you see a pneumatic actuator. It's got a bracket, and the damper shaft is just visible at the top of the picture. Well, we're not going to try to do anything other than simply take everything off and direct couple right on top of that damper shaft. We will keep the old base as a nice way to mount the anti-rotation strap. So the same damper there is over on the right side, and you can see where the actuator has been direct coupled. and the base below the actuator is the same as the pneumatic base that was there. Where to go get information? I think access to information is the most important thing. You can't remember everything. So the website is the belimo.us and then /fire smoke. That gets you to our retrofit pages and all kinds of instructions. And you might note that the instructions start with the name of the damper manufacturer. There are some specifics, although I would say 80% of the time it's the same old thing over and over. There is a cross-reference along with a lot of pictures of the old dampers. And then there are any number of specific instructions. So that website really can guide you through a lot. I'll take questions now. I know we won't get to all of them. If you do have any questions, there's my email address. I'm happy to answer anything. If you've got a specific retrofit, the part number of the actuator is not often helpful. I really would like a picture of both the actuator and then pull back and get a good picture of the damper. And that's for me or for any of our tech support people. They all deal with this.
Excellent. Thank you so much, Larry. We do have a lot of questions that have come in. If you do think of any right now, please type them into the question box. We will not get to all the questions today, but Larry will be happy to answer the questions as he gets them, and you will receive an answer via email. But let's take a couple since we have 1 or 2 minutes left, Larry. Can you repeat how often life safety dampers must be tested?
There are a few local variations calling for more often, but the NFPA 80 and 105 require every 4 years for commercial dampers, every 6 years for hospitals, and if they're in a smoke control system, every 6 months if they're dedicated, once a year if they're non-dedicated. So 4, 6, 6 months, 1 year. And that's the same for almost all your life safety equipment in a building, at least once a year for testing and making sure everything's okay.
Thank you. What permits are required for replacement?
Varies by jurisdiction. In general, this is considered a normal repair and no permit is required to replace an actuator. And now if you're going to get a job with 20 or 50, whatever number you feel comfortable with, I would call up my local building official or fire marshal and ask them if you need a permit for it. Pneumatic to electric replacement, you're going to need a permit. The other time you need a permit is if you're making any structural change. A lot of times there's big space constraints and you got to remove some drywall or any part of the duct to get access, then you should get a permit if you've changed anything there. You should also get a permit if you've touched any fire alarm wiring. So if you're dealing with the smoke control system, a Chapter 9 application, you're going to need to retest that alarm system if you've touched any of the wiring. It might require a permit. It may just require what NFPA 80 and 105 say is leave a record on premises. And that's the general rule for almost all cities.
Okay, thank you, Larry. That's all we have time for today. I want to thank everyone for attending today's webinar, and also to you, Larry. Please rest assured that you will get your answers to your questions via email. And also please join us for our next webinar, which will be on June 17th at 2 p.m. Eastern Time. And the topic will be Belimo's industry-leading retrofit solutions, presented by Steve Lopes. Thank you everyone again, and have a great day.
No, thank you.